First of all, I'd like to thank you for lasting this far into the day. I'm sure it's been quite intense. I've sat in on quite a few talks today myself, and it's nice to see familiar software packages named effectively, and sort of keen eyes for innovation and keenness generally for innovation. So hopefully I'll be able to shed some light on what the institution is trying to accomplish here. With me behind the helm, I guess. So essentially, the talk is the original talk was called Digital Safari, touring the future trends in structural engineering. The reason for that is I'm not really going to be able to delve into the details of what computational methods you can use right now in your offices, in your design practices, or in management. Instead, we're going to have a look at a bit of more of an overview, say from a hot air balloon, through some binoculars at some of the potential benefits of using computational design tools. So first, I'll talk about me a little bit, just 2 slides. Then I'll talk about some myths about computational design and what you've heard may be wrong, and you may be spot on, who knows. And then I'll show you what the institution is doing to promote these techniques and help you all implement them. All right, see if this works. So I graduated in 2013, and my structural engineering experience is within a small practice. I used to be a structural engineer, a graduate structural engineer, then a project engineer, and then something in between that and a senior engineer. Well, it basically was a senior position at Fluid Structures. I believe it's now defunct since I left, unfortunately. Have we all heard about that, have we? Yes, they were purchased by MLM just before I left, unfortunately. It took me about 8 months to get bored with designing pad stones. I got bored. I didn't want to do it anymore. And so I began to learn how to automate those processes. Learned a bit of Python. It's a programming language. It's very simple. It's almost like typing instructions in real English, well, almost. And I began to automate some of the more mundane tasks. And that was the start of my affliction. Effectively, it ran rampant, and I fell into the computational design world, building 3D printers out of bits of string and things I found out in my garage. Got into the whole Rhino, Grasshopper, visual scripting and the complex geometry side of things. In 2016, unfortunately, the infection spread to the rest of the practice, and I was given some Kacha, an architectural assistant, to help me with effectively a few competition bids. We didn't win that one, but it was nice looking. We had a couple of 3D printers, and I began training people in the office. The Fluid Structures were bought out, and when some of the enthusiasm dried up after Fluid were bought out, I used my credentials as what effectively amounts to a dork to come to the Institution of Structural Engineers. Apparently they needed somebody. So in late 2017, I began working for and with the Digital Workflows and Computational Design panel. Took a few months to get my feet, but we began building connections with other organizations, Royal Academy of Engineering, the IASS, the International Association of Shell and Spatial Structures, who were pioneers in computational methods. And importantly, we began building ties with software developers and software manufacturers, developers basically. A lot of this culminated in the Digital Design and Computation Conference earlier this year. Big success, really, really good turnout and lots of enthusiasm there. And all the while we've been building the institution's technical resources in the background now. So, what's computational design? Let's do a bit of myth busting. Just nods or hands if you're feeling brave. How many of you currently use digital tools in your daily practice? Hey, presumably you all signed up on the internet for this conference, right? So I mean, it's a digital tool, right? How many of you currently use computational design tools? Wow. Okay, that's actually unexpected, which is brilliant. So, for those of you who don't think you use computational design tools, computational design tools are special. That's the first myth. Reality is that computational design is just about defining, documenting a design process in a structured fashion. Tools are simply calculation engines. You could do it on the back of an envelope. You could do it on the back of a larger envelope. You could do it on a spreadsheet. Computational design tools generally include spreadsheets, design codes, and even a pencil sometimes, frankly. All right. Myth number 2: computational design tools are expensive. Some of you may already have them packaged with software you already use, actually. For example, if you use Autodesk products, you generally have access to Autodesk Dynamo Studio, which is a automation platform for Autodesk products generally, and I think it can export to other formats as well. And importantly here, there are vast repositories of free resources for those of you wishing to learn to program. And for those of you who are not sitting on your hands all day, I will explain how the institution will be helping you to sort of sift through a lot of these free resources available out there for you. Myth 3: computational design tools are only for sculptures or complex geometry. No. These projects generally have the budgets and the complexity to require such tools, but there are opportunities to reduce time spent doing tedious tasks in small practices all over the country, all over the world, and even for small and comparatively simple projects. Computational design is inaccessible or necessary for small practices. Well, I think by the fact that most people here use them, we know that's not true. And I think, judging by the talks that we've heard today, especially some of the initial workflow design talks, and of course one from this afternoon from Toto Sinji, well-designed digital workflows and well-designed tools reap dividends when used flexibly and intelligently. Computational design is about breaking down complex problems into processes that will help you improve speed, reduce waste, and help communicate effectively. That comes back to the quality questions this morning for Tony, actually. Computational design is really just about defining and documenting design process, structured fashion. Tools are simply the calculation engines. For those of you who are put off by computational design, potentially, effectively what we're talking about is loads, geometry, goes into calculation, outputs moments and forces. That's your general structural analysis process. Of course, we can generalize that more into, say, something a little bit more ethereal, less quantitative. You could say take architectural geometry, we can rationalize it and generate some sort of structural geometry from that. Of course, it's a little bit more complex, and we can then layer this again and again and again and again. We can take architectural finishes and rationalize those into structural loads. We can take empirical data, select the relevant data, and obtain material information. Of course, this is all what you do with the codes. This is the BS, the International Building Code, the Eurocodes. It's all the same. The difference is that we're trying to codify these processes such that we can automate them, in effect. We may take site info, extract the data, extract setting out from that data. And then we begin to piece all those bits together. And we build a process with computational design thinking. And we can derive a model that takes the complexity of a real-world design and applies a codified, documented, and auditable process, coming back to the quality questions this morning based on the ISO 9001. And it's different from BIM. The reason being is that it's a design process. It's not simply the documentation or communication after the design is completed. We can alter, for example, parameters from, say, site info, and these data cascade down through the process, and we produce moment design forces. We can take those moments of design forces, pop them into element design, as we usually would, and we can iterate on that again and again and again. You could do that by hand, don't get me wrong, but the fact of the matter is that digital tools allow you to do it quicker, repeatedly, and without as many errors as you would otherwise create by hand, potentially. providing you audit your processes. Computational design thinking also offers quality, efficiency, design processes. The ability to automate mundane, tedious, and repetitive tasks, quickly offer our clients better structural options, allow them to see detailed comparisons between designs. Now, this comes back to what was spoken about this morning with regards to communication. Communication is often lacking in our industry, generally because we ourselves have not got a clear, documented process about how things are designed, why we take the decisions we've taken, where those decisions have been taken, and how those offset and compare to other design choices. This is the whole optioneering idea. And if we can produce workflows which are interrogable, we can then produce detailed designs based on those processes. And we can produce detailed comparisons for our clients effectively. And of course, the classic, free up mental resources and time for more meaningful design decisions generally. The importance of workflow design. How many of you in here have a documented and codified workflow in your practice? One. One. So for those of you who don't, let's have a look at this, right? Well, I'm using this quick energy supply analogy. I've got a power station on the left-hand side. I've got a building which needs power on the right-hand side. All right. We've got here a potential workflow. So the electricity goes into a truck. Truck charges at the batteries. Batteries goes across the road, discharges those batteries right into the building. Does anybody here think that's a reasonable thing to do? No, of course not. And this is the crux of the problem. We are losing power. We are losing, effectively, effort and resources in transferring data between different packages in a disjointed fashion, causing repeated work and overall loss of efficiency. Now, I'm not going to show you how to map a digital workflow. That's coming later. But the point is that you should be able to understand what your outputs are. You should be able to understand how to get those outputs through a process, and you should be able to understand how to map tools to that process, whether that be Excel, that pumps into Revit, perhaps. Maybe a robot pumps into Revit as well. Maybe the architect's using Bentley MicroStation, and you need to figure out a way to get that data into MicroStation. Maybe you need to output pile loads or a 3D model in Revit. But the point is that without clear communication as to how that data transfers between packages and how to map those pieces of software, or in some cases hand calculations, without actually mapping them, you don't know where efficiencies can be made and sort of savings can be made. It may be that your workflow is actually broken, as is the case with many. Who here has experienced the idea of taking a structural model, putting it into Revit, making changes in Revit, and going, "Oops, that now doesn't work in the structural analysis packages because it doesn't node out," or something similar? I'm sure we've all experienced this. No? Yeah. Okay. Right. Yeah. And what do you resort to? Hand markups. What do? You print out the Revit drawings in 2D, mark them up, send them back to the graduate engineer or something, and he pops it back into. He makes the adjustments in the finite element analysis. Well, without a codified workflow, you can't see how you may be able to reap rewards from perhaps learning to script using free tools such as Python or Microsoft PowerShell, which are included within Windows. The point is, it doesn't have to be perfect, it just has to be better than it was. You have to really understand what you need in order to map your tools and software to it. I think that's been echoed all day, basically. And also keep in mind, it doesn't just have to be engineering calculations. Businesses deal with much more information than just engineering calculations or drawings. I think we've established that now. I'm not going I'm not going to patronize in that sense. But so from a personal perspective, if I was a sole practitioner, and I'm not, and I don't know much about being a sole practitioner, I would think twice before renaming files individually, for example. Why? There's no need to do this again and again and again when you can write a script, which is one line that will do it for you. You can set up rules for emails, autosave email attachments instead of doing it manually into your filing system. There are potential savings there. And these are really simple tools. We call these quick wins in the panel, effectively. And slowly but surely, as you build these quick wins, you can begin to link them together, as we spoke, as a previous presentation alluded to. Automatically forward emails about certain subjects. You've delegated this somewhere else. Why don't you delegate the actual forwarding of the email itself as well? There's no need for you to spend and expend mental effort to forward on emails when you could be doing something more important. This is especially important when your overheads are high and your potential project flow is actually low. Need to save files from planning portal. There are single-line scripts for that. Don't go through them all. Right-click, save to a folder, try and navigate to the folder. There's no need. There's no need. There are single-line scripts to do that for you, and you can get people on platforms to code these for you, places like Fiverr, for example. And worried about keeping data safe. Schedule regular backups with a task rescheduler. I mean, this is simple. And it may not be a massive issue, but when the time comes, it can save your practice. There are events that are effectively practice ending, ransomware, for example, or viruses on servers. And if you've got one of these so-called fake clouds, then you may be in trouble. But scheduling regular backups takes that out of your mind, and you can automate that as well. Setting up a new project folder. This is a good one, actually. I, myself, was beginning to set up folders manually. You'd set up the folder structure, of course, and you'd take documents and you'd go through the documents, renaming them each, and then you open them, and then you change the job number, and then you change the address, you change the date, you change the reference code, you change the address. Why not write a small script that will populate the folder automatically, customized with documents and address, number? It's very simple to do. It's very, very simple to do, surprisingly so, in fact. And with software that is free and available on your computer now, effectively. Right. So what's available? Well, you've heard a couple of bits and bobs today. I'm going to introduce just a few more. I don't think I've really heard anybody mention Python generally today. Maybe. Can't remember. But I know I spoke with a gentleman during lunchtime who was a big fan of Python. There are other programming languages as well. They're free. They're free to use. PowerShell allows you to do Windows operations and file operations. That means copying, deleting, refreshing, renaming, all that kind of good stuff really easily, really quickly, and for free, again. Platforms such as the one previously mentioned, for example, Zapier, effectively what they do is they automate tasks for you, transfer things between platforms. And IFTTT, which stands for if this, then that, gives you an idea of what it's about, are rule-based automation tools available for you for free online. Some are paid, others aren't. And of course, there's the whole digital ecosystem, which is probably slightly a little bit more expensive. Microsoft Flow, for example, is a very similar tool to if this, then that. Allows you to link Microsoft apps. Excel, you can automate plenty in Excel. Revit, Dynamo Studio, and of course the classic computational design poster child, Rhino and Grasshopper. Right. So, I haven't really told you much, really. I've just given you a sort of bird's eye view of what the computational world actually involves. And there's no way I'm going to be able to teach anything of actual use for you to go home with today. But what I can do is I can point you to institution resources which we've been building over the last couple of years, which effectively aims to help practitioners, both small practitioners, medium SMEs, all the way up to engineers in large firms, whoever needs and wants them effectively. Available in upcoming resources. Of course, TSE, a structural engineer magazine. It's the digital design issue from a few years ago. Lots of great info in that. Content related to computational design. It's available for viewing now. More content is published regularly. I mean, just keep an eye on the magazine, effectively. That's an easy one. Our technical resources. The institution has a growing repository of information related to digital design methods. There's a selection of videos just there, digital fabrication, BIM, digital computational design, optimization. There's introduction to scripting, if anybody's interested, which is quite a popular one. And of course, there's the standard guidance on finite element analysis and the like. This is growing every month, effectively, which is nice. It's available also via the institution's YouTube channel. Outreach. We're engaging with software industry more generally, primarily within the structural design field, finite element analysis, element design, software, etc. And we're looking to promote features and license agreements suitable for our members. We know that these things can be expensive, and we encourage you to get in touch so that we can forward your ideas and concerns to basically the software vendors which we are in contact with, in order to push them to produce license agreements which are more suitable perhaps for small to medium enterprises. We also support projects relevant and beneficial for the industry as a whole. I say support, of course, generally speaking, it's about putting them in touch with appropriate contacts for whatever they happen to be doing. There's some interesting stuff going on there. Upcoming initiatives, Structure and Code. This is a sort of meetup interest group, which should be coming up soon. We've had a sort of beta test of it, to use it. And we're hoping to share skills, knowledge, and collaborate on building tools which help people do their structural engineering design work on a daily basis effectively, and develop new ideas. I mean, it could be that people turn up and come up with something crazy and get shot down, but it's fine. It's a safe environment where people can come, develop their ideas, and learn a few things about computational digital engineering. What else? Online technical resources. Again, the repository is growing. Repository for information related to digital design methods. There's going to be quick start guides for individuals, smaller and larger practices, and technical resources specific to digital engineering. Some process diagrams, which you can see just there. And with any luck, fingers crossed, Jane, Digital Design Computation Conference next year it's being hopefully planned soon. So please look out for that. And if you're interested in previous year's Digital Design Computation Conference, earlier this year, apologies, which was March, that's available on the institution's website, the YouTube channel as well. You can go in, have a look, see what things we've discussed and spoken about. Some nice panel discussions on open platforms and linking up software. It's really, really excellent, actually. Right, I think that's it. Thank you very much.